Okay, Will, we're on YouTube now, so that's set up. And I'll just hit record when you start, and then Roberta's going to push out the attachments in the chat.
Okay.
So she'll be in charge of that.
Okay, perfect.
Hey, Will, I just sent you the YouTube link to you privately over Zoom if you want to share it with anybody. But I mean, it's on the web pages and everything. I
don't know who I would share it to while I'm sitting.
Yeah, feel free to drop it in the main chat to everybody once they join in. So, but it's on the web page and they're watching here anyway. So,
okay,
it's there if you need it.
All right, sure. I mean, if you want to push it out to everyone, my guess is that other participants might share it more than I would.
Yeah, like if they want to share it to somebody else, I know a lot of NOAA people were using that yesterday.
Okay, sure.
Hey, Ryan.
Maybe Roberta can push it out, or Tracy can.
Yeah, would you just send it to Roberta in our or
Roberta in the what?
If you want to send it to me and Roberta in the Hangout, or just me.
Okay, I'll do that.
Okay.
All right. Well, good luck. I'll check in frequently, but I'm gonna check the other one real quick. So good luck now.
Okay.
Thanks, Ryan.
Hey, Will, how are we doing this? Are we, I have like all the other, like the links you sent out, but are we gonna have like separate Zoom things that we go to?
Yeah, Tracy will break us up into breakout meetings after the break.
Oh, okay.
And so, yeah, you'll just like disappear. You'll kind of be hanging in cyberspace for a few seconds, and then you'll all land in a Zoom room with a dozen or so of your closest friends.
Okay, so I haven't missed any information in that regard yet.
Nope.
Okay, thank you.
Nope. Great. Looks like it's 8:30, so we can go ahead and get started. Ryan mentioned to me that we're also broadcasting on YouTube. So as far as I know, this is the first land model working group that's ever been broadcast on YouTube, so joining the 21st century. And I also wanted to just let everyone know ahead of time that this is the only one of the working groups that's really doing breakout discussions. And so your feedback here is really important to all of us. And I think tomorrow sometime, Elizabeth will send out a survey kind of asking for responses. And I definitely would appreciate your feedback on that survey about how you think this went, what things we could try differently, and what things worked well. So Roberta should be pushing out an agenda for the meeting on the chat. And we'll try to use the chat as much as we can to kind of have a back channel of communication during the presentations. But this morning, I wanted to share kind of an overview of what we'll be doing for the next couple of days during our discussion. And then I've asked Dave to provide an update on CTSM and some other work that he's doing. And then we'll have 3 presentations from Charlie, Rosie, and Jackie on some FATES updates, since our discussion today is about merging CTSM and FATES and how to do that. I think it's important that we all have a kind of modest level of understanding about what both CTSM and FATES are doing. So Yeah, as many of you hopefully saw yesterday, Dave won the award for the CESM Distinguished Achievement Award, and a lot of that is because of the growth of CTSM. And so in the last 6 to 8 months, we've kind of had an expansion of the leadership roles of CTSM, with Dave heading up the CTSM leadership, Donica is heading up leadership on the crop side, and then I'm the co-chair of the Land Model Working Group now with Charlie. So the three of us are kind of taking on more of a leadership role, helping to spread Dave's burden a little bit into these 3 camps. And then on top of it, we have FATES, and so I put pictures of Rosie and Jackie up here, but there's obviously many more people involved in the CTSM effort, many more people involved in FATES. And to a certain extent, we kind of have this square peg round hole problem, in the sense that CTSM and FATES have been developing alongside each other, but not really being integrated well. And so that's what I want to spend our time talking about over the next couple of days. Before we dive in, probably by the end of the summer or early in the fall, we'll have a CTSM 5.1 update. So that includes a number of parameter changes that Keith has put in related to PFT reflectance and new urban data sets. Sean also has a pull request in for biomass heat storage, so that should be coming to the trunk soon. Sean and Bill have been working on irrigation, which is in the model now. CTSM will have improved some bug fixes and improved deforestation fires, and a lightning bug fix from Fong Lee. Leah Birch has both some bug fixes that I'll talk about in a minute here, as well as some science changes to Arctic and boreal phenology and allocation. The matrix CN work from Chris and Yichi is very close to being finished, which is exciting, and that'll be critical for some of the work that Dave's talking about. And then Julius Vera and Peter Hess from Cornell have prognostic NH3 emissions from the FAN model that also have a pull request that's nearing completion. Peter has implemented shifting cultivation. I've put that in with the crop model. It's really more of a land use change activity. And then there's also a recent pull request that's been completed from Yang Yan and Mao Yi on bioenergy crops we heard about at the winter meeting. A number of features are also will be included in the release. So that includes removing some hard-coded parameters that Keith has done for the parameter perturbation ensemble that Dave will talk about. There are new SSP, RCP anomaly forcing comp sets that we can use for land-only runs. There's also, sorry, I'm seeing in the chat that there's no sound, but it looks like people worked it out. There's also prescribed soil moisture, as well as greater flexibility in snow and soil layers for trimming both the vertical resolution of the model and the number of PFTs on a grid cell for faster throughput, which is important for numerical weather prediction simulations. So along with those pull requests, I wanted to kind of draw your attention to one bug. This is the Luna bug. I don't want to go into a lot of detail on this. So this is a bug, it's actually 3 bugs that Leah Birch found in the process of her development. And there's quite a bit of conversation on GitHub, on our GitHub page, if you want to follow that. So one of those was that max day length was hard-coded to 12 hours globally. I'll talk a bit more about that one. Average day values are needed for Luna. And so we needed both day and night, not just daytime values, which is what was being done. And then there was the hard-coded initialization of VCMax and JMax that was inappropriate. And so I put one of these on here, the first bug with the max day length. And I put it on there because there's this parameter in the model called JMax B1. And as a result of this bug fix, what we get is much lower Arctic VCMax and therefore productivity. And because this parameter is also was lower in CLM5 than it was in the original Luna paper, we've decided to adjust this parameter with the bug fix, as well as modify some other Arctic specific parameterizations for leaf carbon to nitrogen ratios and SLA top that are more in line with observations, and kind of this has been kind of a long process in conversations with Chungying and with Keith and Leah and me and Dave and others. But the kind of take-home story is that, I apologize, these are a little granulated. This is what GPP looks like with the bug fix minus the control. And so the result of the bug fix and the parameter changes is you get lower productivity in the high latitudes, slightly higher productivity in the tropics. And on balance, these are more in line with observations. These are present-day simulations. Just kind of testing the effect of the bug fix. So we feel comfortable putting this in as a bug fix, although we do acknowledge that it's going to change answers, hopefully for the better. Or it looks like from this for the better. Keith's also run ILAM on the bug fix, and it does indeed look better across ILAM too. So some other highlights that I wanted to touch on. This is kind of an ongoing conversation with NSF and a proposal that Gordon's working on for a NEON NCAR cyber infrastructure project. It's really focused on the cyber infrastructure piece of it and forecasting. So Gordon and Mike are kind of heading this up along with Brian Dobbins, who's now has moved to a software engineer in CGD. And Donica.
When you do that, you can integrate to get a total mass, and you can get a representative number the second moment of that distribution, or another moment of that distribution if you define its form. And then you can analytically do a lot of the same calculations you would do on a bin scheme. You can also, if you reduce that to a 1 moment scheme, you just have the prognostic mass and you make an assumption about this size and you make it diagnostic, and it sort of reduces to this with some representation of a functional form. So in the current version of CAM, we're obviously using a 2 moment scheme, 2 moment bulk scheme that has a number of different classes. The evolution looks like this. We started in CAM 4 with that was a 1 moment bulk scheme. In CAM 5, we introduced
a little ambitious, but we're going to stick with that timeline. And so a couple of the features that we'd like to have active in CESM-3 are hill slope hydrology and FATES. So Sean's put together the hill slope hydrology model. And that offers some really promising ways of looking at hill slope and catchment integration of water and energy fluxes. And then Rosie, Jackie, Charlie, and many others have been working on FATES. And we want to be able to run full transient historical simulations with FATES in CTSM-4 as an option in CESM-3. And if we get far enough, as the default for CESM-3. Other priorities for the land model working group are that we're really aiming to improve the representation of land management, including the improvement and increased flexibility of representation of the crop model, agricultural practice, rangeland and pastureland, water resources, water management, including a full two-way integration of rivers, lakes, reservoirs, and reservoir management. There's also talk of having managed plantations and managed forests and plantations. And really pushing out the boundaries of what we can do in terms of crop and water management with the model. I think that's one of the features of CLM5 and CESM2 is having this active crop model. So Donica, as I said, is leading that up with help from Bin Peng, who's interested in applying the AppSim crop model into CTSM, and then Naoki is working on the Mizura implementation for the river model, which will allow more flexible implementation of rivers and managed waterways. So kind of putting those all in a list for CTSM-6 and CESM-3. And again, the daunting part of this is that we really have a year to work on this. So Dave kind of joked around in his talk yesterday about pulling CLM5 across the line, and I think in many ways pulling CLM6 across or CTSM6 across the line will be just as much effort, mostly because of all of these interacting pieces that we need to figure out how to make play nicely together. So a way of saying that kind of pictorially is that we have a model like CLM or CTSM. And all of these components work well on their own, and we really don't have a good sense of how to integrate or how best to integrate. So how to integrate FATES and land use change, or the hill slope model and land use change is kind of an outstanding problem that we'll talk about more today. And then opportunities too to think about how FATES might interact with the hill slope model or how the crop model and the addition of Mizzou route and managed waterways will improve or will kind of open new doors for science and questions moving forward. And so in thinking a little bit more carefully about CTSM and FATES, we really are kind of these two communities that are relatively siloed, and the idea is that, within a year, we want to be running fully transient historical simulations of CTSM-FATES. And in talking about getting ready for this meeting, Jackie noted, like, I've never run a fully transient CTSM run, and then I responded, I've never saying that about the other one's modeling framework. It's something that we need to kind of rectify. And so, a huge aspect of what we need of the discussion here is to start thinking about this integration and how do we bridge the communities that are working in CTSM and FATES so that it's more than just Charlie and Rosie. Right now, those are the only two individuals that I know that are really doing this integration. And as a community, we need to be better at doing that integration. And so, like I said, the goal is that within a year, we want to be able to run CMIP compatible, fully transient historical simulations of CTSM-FATES. And so the discussion of our meetings, for the next several hours today and then extending into tomorrow is to prioritize the needs that prioritize the needs to make that a reality, and then identify the specific tasks and interested people who can implement the CTSM-FATES integration. And so that's it for me. Maybe while we're transitioning over to Dave's presentation, if there's any questions on the chat, feel free to put those up, or if you want to raise your hand, Dave, it looks like
I just want to make a small point of clarification that the release of CSM3 would not be next summer. That would be the first attempt to start integrating the model components.
Yep, that's right. Thanks.
Which is probably unlikely, frankly, but let's still work like as if it might happen.
Yep. Thanks.
Hi, this is Alan Roebuck. I'm kind of new to this, and you talk about Rosie and Charlie. I don't know who they are, so could you maybe identify these people?
Oh, sure.
Their last names too.
Sure. So Rosie Fisher and Charlie Koven, as well as Jackie Shuman, will all be presenting after me. So they're kind of the three folks that I've pegged here to introduce FATES and to lead some of the discussion about FATES. Dave, do you want to see if you can share your screen? Great. And if there's no other questions, Dave, go ahead and take it away. You might have to unmute, Dave.
Okay, hear me now?
Yep, that's better.
Okay. Okay, so this is going to be the one non-FATES oriented talk, but we felt like these were other major activities that people might like to hear a little bit of an update about. Since we're not doing just general presentations in this workshop. So I'm going to give an update on CTSM, and in particular, a WRF CTSM coupling. And a lot of this is focused not really on the climate problem, but I think there's still going to be a lot of people across the LMWG working group who are interested in using this capability. In the long run, we are hoping this is going to facilitate the transition of land model research, all the work that we've been doing, for example, into operations for numerical weather prediction. But that's a big, challenging political minefield, and we'll see how we go on that. I'm not going to go through this slide because I've shown it a bunch of times, but we are unifying CLM and the NOMP model at NCAR to form the community terrestrial systems model for lots of reasons.
So it's about 46 after. Maybe we have time for one question. And
you want me to just take them out of the chat and read them? Would that be faster?
Yeah, sounds good.
Okay. So Julio, rhyme dice is grapple or hail, and it gets important at high resolution. So you know, we start to see it at 14 kilometers. It moves around where precipitation forms. And then Michael says, the winter meeting, we mentioned switching warm process rates from KK to Cypher and Bahang. Is that still the plan? I'd like it to be the plan. We can do that whenever we want, just has to be in the tuning. I think we should also be changing up some of the parameters for our deep convection in default, and maybe we want to do this all at once and only tune it once. And then I'll answer the other ones, Peter, in the chat. How about that?
That sounds perfect. Okay. I think Minghui, I think that you're up next.
Pause it for the next school year. And
I think one of the person have the mic unmuted.
So Aaron's gonna try to facilitate.
Can we try to mute everyone first and then
somebody's unmuted.
All right, I'm going to share my slides now. Okay, so today I'm going to talk about ice microphysical properties below -40 degrees Celsius based on 7 NSF flight.
Minghui, you're not sharing.
Oh, geez. Right.
Sorry, I didn't release it quick enough. You pushed the button too soon.
Right.
And Minghui, I'll give you a 10-minute, a 13-minute, and then a please stop. Okay?
Yep, absolutely. Okay, so I'm going to try to get this out. Do you still see this? Oh.
Yeah, we can see your screen now.
Okay, so I'm going to talk about the ice microphysical properties based on 7 NSF flight campaigns and the NCAR Chem6 model simulation. Most of this work is done by my graduate student Ryan Petnod, and we're also collaborating with Xiaohong Liu and Su Qianchu. So I want to thank all the flight and ground crew from NCAR, NCAR REF, and all the science teams at NCAR. It is very important to represent cirrus cloud correctly in climate model. So they cover up to about 30 to 40% of Earth's surface. And if you misrepresent the clear sky supersaturation and as cirrus cloud, they will cause about 2.5 watt per meter square average radiative biases at the top of the atmosphere. As you know, cirrus cloud can block some of the shortwave radiation, but the clear sky supersaturation, which is just water vapor, cannot block some of these shortwave radiation. So today I want to focus on, let me see if I can get rid of this box here. Today I want to focus on what are the effects of dynamic condition on cirrus cloud microphysical properties, what are the aerosol indirect effects, and how do models simulate these different properties of cirrus cloud and the factors affecting them. So here are the 7 flight campaigns from NSF, and we have a composite data set that range from 87 degrees north to 75 degrees south. In total, we have 1,000 flight hours, and the analysis are restricted to temperature below and equal -40 degrees Celsius. And we have a horizontal resolution about 230 meters. That's for the aircraft data. For the instrumentation, we use VCSEL hygrometer for measuring water vapor. It is not very easy to measure water vapor accurately. So in the past, we have used 2 different systems to calibrate the instrument. There's an oil path and there's an environmental chamber. So the goal is to calibrate this open path hygrometer, which is sitting on top of the aircraft, for all combination of pressure, temperature, and water vapor. And combining that with the temperature uncertainty, the relative humidity uncertainty is about 8 to 7 for the temperature range we're interested. The cloud measurements are all based on the FAST 2DC probe consistently for the 7 flight campaigns. In addition, we have the aerosol probe, the USES, that measures from 60 nanometer to about 1,000 nanometer. And here we have on the bottom, which is all the instruments sitting on different parts of the aircraft. For the CESM-2 Chem6 model simulation, we run 2 different types. One is a nudge simulation, nudge towards the horizontal wind and temperature in the MERA2 data. The other one is a free running simulation. We use the MG2 microphysics for both types of simulation. They run about 1 degree horizontal resolution. And we also try to choose the similar, okay, we also try to choose a similar type of variables between observation and simulation. For example, we choose the same size range for the ice microphysical properties. We try to define in cloud in the same way as the minimum conditions seen in the observation. Same for relative humidity, vertical velocity, use similar way to calculate it. And the aerosols, we group them into two different categories, larger ones and the smaller ones. Now, the first thing we take a look is the regional variability. So we compare among tropics, mid-latitudes, and polar regions. We have the black line for Northern Hemisphere, solid black line, dashed line for Southern Hemisphere. And all the blacks are observation and all the red are model simulation. First thing we see is that there are higher ice water content and Ni, which is ice crystal number concentration in the Northern Hemisphere mid-latitude than Southern Hemisphere mid-latitude, as this stands out. And also we see higher Ni in tropics than polar regions. The Chem6 model consistently show smaller ice water content and diameter, mean diameter, and that's probably underestimating ice crystal sedimentation and growth. There is smaller Ni in the Northern Hemisphere mid-latitude, and that is probably underestimating the aerosol indirect effects for the mid-latitude region. So most of these results are actually submitted to ACP and it should be online and accessible in a few weeks. For the effects of relative humidity, we want to see how do thermodynamic conditions change cirrus cloud properties. So we have ice water content, Ni and Di, plotted on the y-axis, and the x-axis has relative humidity. Now the Ni and ice water content actually peaks around 110%, and the Di peaks about 130%. For the simulation, they have two peaks, which is interesting at 80% and 100%. And this is probably due to the parameterization of ice cloud fraction in the model that uses two parameters, the RH minimum and RH maximum, which locate at 80% and 110% respectively. So this may be the parameterization not exactly following the physical processes. Another comparison is the variance of vertical velocity with the W sub variable in the model. So we have on the top observation, the nudge and free run on the bottom. Both the observation and the model show increasing trend of ice water content and Ni with the increasing sigma W. But the simulation actually show lower maximum sigma W as a cutoff right here. So this is possibly due to missing gravity waves from topography, fronts, convection, etc. Now the third effect we want to look at is aerosol indirect effects. In order to isolate,
run a parameter ensemble with CTSM. So it's a multi-step process. This is not a very nice set of slides. It's kind of wordy. I'm going to go through it quickly and refer you to the slides if you want to look at details. But what we're doing is we're trying to identify the full list of parameters in CTSM. We've been scouring the code for, in quotes, all, because it's actually, it turns out it's actually hard to define what a parameter is, harder than you might expect, but we've identified 200 or more. We've been moving any of those hard-coded parameters that were in the code to a parameter file, and Keith Olesen has moved 60 parameters so far onto the parameter file. And so now we have very nice ability to control essentially every parameter within CTSM via the parameter file. And then we're listing all these parameters in a spreadsheet with reasonable ranges. And this is just an example. It's a Google spreadsheet, and each of the, here's an example of the radiation parameters, location of the parameter, and then what is the minimum and the maximum values, either from the literature or from expert judgment. In some cases, we don't know, so we're just saying plus or minus 20%. And this PFT here indicates that there's another part of this document where you can find for each PFT the high and low side. So the nice thing about this, here's another example of going down into the document of stomall resistance and photosynthesis parameters. This is a work in progress, but basically every parameter within CTSM we have in this list and reasonable ranges, which then we can adjust, have people contribute to. And so even just this resource of this parameter list is going to be useful for the community. We're going to define a sparse grid where you can run really fast, a representative sparse grid that can capture the large scale dynamics of the system. And I'm running out of time, so I'm not going to go into the details. We're coming up with a fast spin up technique, actually taking advantage of the CN matrix solution, where we think within about 120 years from a previously spun up simulation, you can spin up to quasi-equilibrium almost any different, any parameter perturbation. Daniel and Katie are developing a very detailed scripting infrastructure and really easy to use scripting infrastructure so that will set up cases, control the parameters, and execute the spin up and ensembles, all with a relatively simple and small number of operations that a user would need to do. And we're hoping to make this, both the scripting infrastructure for the parameter exploration and the analysis scripts will be a community resource. And then we're going to start off with a one-at-a-time parameter sensitivity at the sparse grid for every single different parameter in our list. And one thing we're really going to try to focus on is a couple of things, starting in present day climate and then checking each run for things like survivability rate of each PFT, reasonableness of GPP and ET. And we may be able to use ILAM to do this. We've been able to show that ILAM works, and you can sort of use it. Looking down here, you can look for the area of intersection, whether, you know, the 10.3, whatever the units are for GPP, petagrams carbon per year for just this area of intersection, these points here, compared to the benchmark. If a particular parameter set doesn't pass checks, we can then constrict the parameter range and try again. So we'll do that. Then we're going to do environmental perturbations for each one of those. So looking back at the climate of 1850 or into the future, CO2 of 1850 or into the future, NDEP. Actually, this would probably just be a high side NDEP, just adding NDEP. And again, if on the low side, you know, it doesn't pass our criteria, which, you know, need to be defined more clearly or definitively, but if it doesn't pass the criteria, we can restrict the parameter ranges again. And then we'll go into full Latin hypercube. I'm gonna not go through all the details here because it's pretty complicated. And the idea is that eventually we would get to a point where we can do a global transient 2-degree simulations with approximately 100 interesting, let's call them interesting or best parameter sets, and run a full spin up and transient historical projections to be able to, you know, analyze these large scale consequences of the parameter uncertainty on, for example, the carbon trajectory. So we're going to need people to, especially to help analyze these ensembles. We're going to devote quite a bit of computer time to this from the Land Model Working Group. And, you know, I think it's going to be a really interesting and rich resource for people. So
properties. And the aerosol indirect effect, interesting thing we see is there is a non-monotonic relationship shown in the observation. And there's a sudden increase of these properties, especially at very high value of aerosol number concentration. And we also need to isolate the thermodynamic and dynamical impacts when we quantify these aerosol indirect effects. The model in general show weaker aerosol indirect effect, and there's no sudden increase. So lastly, I want to thank the NSF support that I got to do this work, and also the support from NCAR ASP Faculty Fellowship and SJSU Awards. And I would like to take your questions. Now, let me see.
Okay. Yeah, great job. So do you want to read Elizabeth Moyer's question, or do you want me to?
Right, so I'm gonna stop share and then I can see the questions.
Sounds good. Or I can just read it to you. So question is, what is the observational cutoff on DI? The observed DIs look very large for these temperatures.
Oh, that's a great comment. So for all of the fast 2DC probe, we actually cut off at 62.5 micron. That is a very good point. And we're actually surprised that even at these very large sizes, we still see aerosol indirect effect pretty clearly for ice water content, NI, and DI. We were able to analyze different sizes in the model, and the difference between the model and the observation do not seem to get smaller. So the model doesn't get better result just by including all the sizes. That we know, but the next step would be if we can have many campaigns with small ice measurement, then we can do the aerosol indirect effect just on those small ice.
Great. Okay, we're back on time. Thanks. Rich, do you want to set up now?
Can you hear me? Yep.
Yeah, we can hear you.
Great, here we go. And can you see that?
No.
Ooh, how about now?
Not yet.
There we go.
How about now?
Okay.
You got it?
We can see it now. Yeah.
Cool. All right.
I'll give you a 10-minute warning.
10 second. That's brutal. All right. Oh dear. Sorry. We good there? Yeah. Okay.
Yeah, that looks good.
Good. Sorry, I'm two screens here. So yeah, so good morning. I just wanted to go through some initial analysis that we've been doing at NCAR across LES and across single column version of CAM6, a little tiny bit of CAM5, but essentially I'll describe some of this activity and then I'll describe a case study we've constructed and looking at, and then some CAM, and then a little bit of LES comparison at the end. So this is kind of work came out of activity at NCAR across the labs. So the intention was to kind of consolidate and make best use of the expertise, the modeling expertise, observational expertise. For the one purpose is multi-scale parameterization development. This involves a number of LES models, so we get to really probe some very different models, the kind of well-established NCAR LES, a WRF version and an MPAS version that is coming online soon, and then a pretty new LES called a FastEddy, which is kind of optimized for GPU. I'm not going to go into details of the configurations of LES. That would take a lot of time, of course. And the intention is to compare that with column models for us, SCAM. Now that piece kind of attaches to the observational capability at NCAR, and there's this potential new observational system, this Lotus system that will enable us to essentially, sample a little bit more usefully for the quantities, the flux covariance, et cetera, that are used or parameterized in the models. And then finally, all this has to be wrapped up in something that's useful across all these platforms in terms of data and analysis frameworks. So that's briefly on that. So the case study we're involved with right now was part of the Southeast Atmosphere study. So this is a kind of umbrella of studies, one of which is people are familiar with is with this NOMAD study, and that took place in the summer of 2013. So this is a kind of simple surface boundary, flat forested boundary, and because it's forested, there was also, as well as the meteorology, boundary layer growth, et cetera, there was a focus on photochemistry, volatile organic compounds. The specific case, it's an ideal composite day of surface forcing. You see there, the latent sensible heat flux, pretty simple analytical forms over daytime in terms of increasing at a peak in the early afternoon.
So rather than going into the sort of the theory of what's in FATES, I'm going to show this video that I've made, which many of you have, I'm sure, seen, of what it's showing is sort of 600 years of transient dynamics of ecosystem structure, sort of under steady state conditions for a tropical forest site. And each one of these sort of popsicles represents like a cohort of trees. This is made using sort of annual restart files of this sort of evolving forest structure. And so the point of this is to show that what FATES is effectively sort of at the most basic level, it's a sort of reframing of the vegetation from modeling the canopy itself as the entity that we're modeling to modeling the trees that comprise the canopy. So it's sort of shifting, from the forest to the trees. And what that does is allow us to do a bunch of things, but what this shows is sort of the emergence of these structurally complex ecosystems. So here you've got two different PFTs, an early and a late successional functional type, existing in this sort of different canopy strata, competing against each other. And click on this again. And as this sort of as the simulation progresses, you've got sort of a newly disturbed, you're constantly generating newly disturbed patch area. And then as the forest ages, you get this sort of older, this mosaic of a disturbance history. And so with the fates, we can resolve.
Excuse me, could you explain what the x-axis is on this? I find this movie very confusing.
Sure. So the x-axis is space here, and basically it's sort of fractions of a grid cell, and basically there's sort of two parts to it, which is the fraction that's occupied by patches with different disturbance histories, and then the area underneath the crowns of cohorts of trees within those patches. So basically cohorts sit on patches and sort of compete against each other. And then the patches of land are a way of tracking the disturbance history of the land, of the landscape. And so there's sort of this mosaic of competing trees or competing plants in space. So it's basically, it's showing the sort of dynamics of competition over space and time for trees of different heights. So that sort of hopefully gives you an example of the just sort of the essence of what FATES is sort of doing under the hood, and hopefully that, it gives you a sense that it's obviously a much more complex representation, but we argue it's a much more powerful one. And to that end, I sort of listed some new types of questions that a CTSM-FATES would allow us to ask. And I've sort of, sorry, there's a lot of words, but basically, things like how do variation in traits within any given biome? So right now, we have this sort of correspondence between plant functional types and biomes, but there's no need for that correspondence to exist. And so within, a tropical forest, we have early successional and late successional, we have drought tolerant and drought intolerant, et cetera. There are a lot of important variations that we can start to resolve with this approach. By resolving disturbance and the agents of disturbance, so fire, drought, windstorms, sort of in the natural category, as well as more specific land use, which we'll talk about later in this talk, we can really resolve some of this stuff. So we can track primary and secondary lands. We can track recently disturbed and more longer time since disturbance, and that allows us to understand both the sort of impacts of climate change as well as some feedbacks. Things that depend on the height of plants. So by resolving and prognosing plant height, we can ask, there are a lot of important processes that depend on the size of plants. So fire, obviously small trees are more vulnerable than large trees, ditto insects, droughts, evolving surface roughness. There are a lot of things that the height is an important process. And so by resolving this and prognosing this height, we can ask more sophisticated questions about how these dynamics work. Ditto sort of basic DGVM things. So right now, CESM doesn't have changing plant distributions. And so there are a lot of key things: forest savanna gradients, forest grassland, forest tundra boundaries. How do those changes in a transient sense, where we recognize ideally dispersal limitations and certainly growth and establishment limitations in a transient sense, how are those going to feed back? I touched on primary secondary lands. How do CO2 fertilization and nutrient cycling, how do those change the sort of the competitive dynamics, thereby affecting the growth, the turnover times, the feedbacks, the carbon cycle? So we're not treating
this one for decades, and Sullivan kind of began this. So on the left is CAM6, this 2 meter, 256. Our supreme version has a boundary layer that goes up to 2.5K. The NCAR LES is much shallower and actually in much better agreement with the observations. We have some celeometer estimates there below, around 1500 maximizing. But there are some caveats to this from the perspective of CAM is running over the top of a interactive land surface. Even though you're prescribing latent sensible heat flux, there is the potential for an influence from the spin up in the surface temperature, which of course would contribute to the long wave cooling or long wave heating aspect of this. And just as an example, these initial CAM6 simulations show how the surface temperature grows. And so we're kind of trying to look at having a more equilibrated, idealized land surface. But in terms of the vertical pattern of the growth of the boundary layer, you do look at this CAM6 on the left and this NCAR LES potential temperature is pretty darn good. In terms of the growth, if anything, there is a little bit of a deception, I think, from that boundary layer that we're using, the calculation depth, because the boundary layer top stability is much lower. I think it's giving a boundary layer depth that is much deeper than it is, because you look at the top right LES, and if you think of d theta by dz, it seems to be actually deeper than the CAM6, so that's kind of encouraging. Specific humidity, again, the difference is, the evolution is similar, but the boundary layer top decrease in Q is much more stronger in the LAS, and the mixing given by the more vertical contours of the Q is much stronger in the LAS. So there's some differences, and that's kind of, you can see that if we look at the vertical fluxes of moisture, and we can really see that in the LAS these are much more maximized closer to the boundary layer top, and there is a very strong drop off in these fluxes. So there's the flux convergence there is very strong. Finally, and in terms of the turbulence in the boundary layer, with this kind of symmetric turbulence, the variance in the vertical velocity, it's not too bad. That top figure a little bit stronger in the NCAR LAS, but the big difference is the asymmetric, the skewness component of the vertical velocity. So there is a lot more kind of asymmetric turbulent activity, it would seem, in LAS. And this is my final plot of comparison with the LAS. I haven't quite got this on the right color bars because these are recent additions, but essentially these are the three LASs compared to CAM6 in terms of potential temperature and the growth of the boundary layer during this time. And quite nicely, I think it compares well with Fast Eddy and NCAR LAS, which are very different LAS. WRF LAS seems to be doing something different, and there may be some problems with that. So give you a quick tour through initial efforts to kind of unify our workflow in terms of developing parameterizations and comparing to observations and models. So strong, CAM6 has a strong sensitivity to a number of things: time step forcing and the coupling frequency in terms of PBL in particular. There is a convergent behavior with increased vertical resolution. PBL stability increases, but it's still weaker compared to LAS. And there is an argument that we should really be using at least 10 more levels in the boundary layer, and that's borne out by these dry boundary layer growth experiments. And the interactive land coupling is obviously a challenge. In terms of the LAS comparisons, clearly the asymmetric turbulent part, the skewness of the vertical velocity is playing a much greater role in the LAS, and there really is a much stronger stability at the top of the boundary layer. And moving forward, like I said, the equilibrated land condition will be much more useful. Chemistry, and then again, more direct validation of these higher order flux components associated with the explicit versions in LAS. Okay, thanks.
Great. Well, it wasn't 10 seconds long, but it was still a very good talk. Thank you. Do you want me to read questions for you, or can you see them?
Sure, I'm not quite right. Yeah. Read questions.
I got it. Okay. So first one from Andrea Malode, and it's, so does it worry you that the boundary layer depth depends on time step, not only smoothness, but mean depth as well?
Yeah, it is a concern, and I've not thought too deeply about the ramifications of doing more frequent. There were three things: the radiation, the time step, and the surface coupling. So the question is, I didn't get a chance to do this, but that's my next kind of job, is to decompose these three things and determine why the boundary layer depth is quite a bit shallower in the default version of the model.
Mm-hmm. Okay, next question from Chris Cruz. How many levels were used in the CAMS
dynamics? The key thing is, so we're now resolving these sort of two classes of disturbance, natural and anthropogenic disturbance. And so you always have this kind of background of natural disturbance sort of churning along, both on primary lands as well as on secondary lands. But now you have this one-way transfer associated with anthropogenic disturbance from primary lands to secondary lands. And so that sort of creates these two categories of patches. Right now they're sitting on the same column, so they're sharing the same soil, water, and when we have the nutrient cycling active, that they'll be sharing the same nutrient dynamics. So that's kind of not ideal. And so our longer term goal is this idea of kind of multi-scale heterogeneity, where the sort of patches are used to represent the kind of gap fall or natural disturbance, I think is typically sort of a smaller scale process than anthropogenic disturbance, where we separate out the columns that the patches sit on. So we have sort of, they're no longer competing for the below ground resources between primary and secondary patches. And when we do that, that then will allow much more flexibility as well. Things like shifting cultivation, changing patches, changing columns from FATES to the crop model, et cetera. But so right now we're sort of in the middle here. We have this sort of version 1 of the land use code that we've got a pull request up right now, and we're looking to, we're at the stage now where we're basically ready to do global testing on it. We've confirmed that it works sort of on regional tests, but we want to do the global test now and see if we get reasonable results. Just some sort of background on how this stuff works. So in Mao Yi Wang's paper, which is in Biosciences Discussions right now. So this is how it works is kind of, I'm going to sort of walk you through it. So you've got on the upper left this sort of original patch structure of canopy trees and understory trees. And then in this B column, we sort of do the direct effects. We figure out what fraction of the trees are logged directly, which ones die as a result of trees falling down and killing their neighbor, which ones are killed because of building roads and skid pads and these kinds of things. So we sort of track each of those. And then next thing in box C, we then say, okay, well, now we're going to split the patch in two. So we have a newly disturbed patch and an old patch. In the newly disturbed patch is basically all of the crown area of canopy trees that die becomes the new patch. So the old patch becomes all the canopy trees that didn't die. Next, we then remove the crown areas of those trees that have died in both patches. In E, we then say, okay, well, actually some fraction of the understory trees are also killed because branches fell or whatever and crushed them. So, they were sort of happy for a very brief instant, they got sunlight and then they were crushed and died. And then in the bottom right-hand corner is sort of what's left. And this is sort of the resulting patch structure of these two new patches, sort of the undisturbed primary lands and the newly disturbed secondary lands. What then happens is, the harvest gets split into different things. So there's the sort of direct felling, which goes into logged products, and as well as sort of coarse-weighted debris and litter, and then the collateral and mechanical damage just goes into the coarse-weighted debris and litter. And then the fractions of all these things become model parameters, as well as what fraction is collateral damage, what fraction is mechanical damage, et cetera. And so this is all sort of the closed canopy case. But for it to work globally, you have to think of it it has to work as well on places where there's very limited forests, where there's savannas. Maybe there's what happens if we try and log a grassland? How does logic handle that? So I made this little schematic to sort of show the sort of more general case of sort of on the left. And now we're switching to sort of top-down plan view from the sideways view here. So we've got these different patches. So on the right, you've got a sort of closed canopy patch where the trees all sort of smush into each other. In the middle, you've got sort of a savanna with trees surrounded by grass or bare ground. Maybe young patch with lots of little trees, maybe just grassy or bare patch. So what would happen with logging in all of these? So in the middle, we're showing sort of we've got a log fraction. So say we're logging I don't know, it's like 15% or something of a grid cell. What is that? So we have this log fraction, then we have the undisturbed fraction. Within the log fraction, we harvest some trees. Maybe we have the parameters right now could be that we harvest all the trees that are above some diameter. And so the smaller trees, we don't harvest those, and they end up being disturbed and surviving into the new secondary land. So you could have some parametric control on what fraction of trees we harvest. But the key thing is that the logged fraction of land, all of that land becomes either secondary forest or degraded forest or whatever you call it, but it's secondary lands. So then we have this new patch that's the secondary patches, there were secondary lands, which then have all of the surviving trees from this harvest event across all these log patches sort of interspersed with them. So you end up with kind of something where we've not changed the composition of the primary lands at all, but we've changed the secondary lands are now heavily disturbed. And so this logic applies, however, whatever the sort of composition of the ecosystem looks like. Okay, some next and later steps. So as I said, we've got this pull request up right now that it's sort of a V1 of this. We've tested a little bit, but we need to do a lot more testing. We want to do
the transition from, let's say, stable boundary layer to dry convection, shallow convection, and even deep convection with one single mixing parameterization. And I'll show you just one result about that. We are focusing on the PBL and the transition to deep convection, both from a sort of spatial transition over the ocean, as well as a temporal transition over land. So in spatial transition over the ocean, we go from stratocumulus to deep convection. If, like say, we go following the trades from, let's say, California to Hawaii and to the ITCZ. And diurnal cycle over land, we'll show our results, but we'll try to simulate the transition from the morning, the stable boundary layer, dry convection, shallow, and then deep convection. So we can go to the next slide, where this is the shortest slide I've ever shown on EDMF. There's a bunch of mathematical formalism and physical assumptions and theory behind it, but in a very sort of in a nutshell, as people say, EDMF is an approach that basically represents the subgrid scale vertical fluxes of properties as a combination of eddy diffusivity that represents the smaller scale mixing and mass flux mixing, which is a way of modeling plumes, convective plumes or thermals that are sort of across the boundary layer depth or the troposphere when we go into deep convection. And the figure at the bottom right is just one snapshot of an LES experiment. So every point is an LES point in the horizontal. It's a cut across, this is the BOMEX case, so it's shallow convection. It's a cut across the mid of the cloud layer and shows you a plot of where the points lie in terms of vertical velocity and the horizontal, and total water, which is vapor plus liquid, minus the mean in the vertical. And you can see that there's sort of two clouds of points. One that is this Gaussian around the mean environmental value, which is essentially the turbulence around the clouds. And then there's a very skewed part of the distribution that is represented by the plumes that has higher vertical velocities and higher water contents. And that's what we're trying to represent with the plumes. Go to the next slide. The next slide shows sort of cartoon of the sort of approach we've been using and developing in the team. There's different flavors of EDMF. This is one of them. The essential component of this flavor is really the idea of multiple plumes. So we replace one single bulk plume that is supposed to be representing an ensemble of plumes in the grid box by a variety of plumes. And the essential reason for that is that this allows us, and that's what happens in our parameterization, is that in one single grid box, you can have different types of convection coexisting. So we don't have to make decisions between is this deep convection or shallow convection. You can have plumes, and we do have plumes that reach just cloud base, and others are just very dry. Then others will be shallow convection, other congestions, and other deep convection. So the idea, as the cartoon tries to sort of illustrate, it's not a great cartoon, but the best I can do. So something is going on. You're going to go to full screen again, I guess, right?
Yeah. Sorry.
Yeah. No.
Just trying to mute people.
So I'll continue. So the idea is that we try to parameterize the PDF of surface layer thermodynamic properties. And now I cannot see the full screen. So before was full screen was great.
You can't see it now?
I cannot see the full screen.
Can other people see it?
Yeah,
no.
I see the. I see
now I can. Now I can.
Okay,
I see it. Yeah.
Perfect.
Sorry about that.
Perfect. No, this is perfect. So we parameterized the PDF of surface layer thermodynamics, which is something that we know a little bit about in terms of we, the community, know a little bit about the surface layer. And then we often use a Monte Carlo sampling of the PDF to produce multiple plumes. So some of these plumes will be more energetic and sort of healthy from the beginning. But on top of that, we also use a stochastic lateral entrainment that tells us something about the probability that a plume will encounter in a training event in, let's say, a certain distance. And this is partly inspired by a paper by David Roms and Jimmy Kwang. And so there will be plumes that are luckier and face less entrainment events and start with more buoyant from the beginning, and they will go further than others. And that's what sort of regulates how far the plumes go, and that's why we can have different types of plumes coexisting in the same model grid box, which is a great asset of the parameterization. So if we go to the next slide, I'll show you just one result. We have a variety of papers on this. So the result I'm showing in the next slide is about the LBA case, which is a diurnal cycle of convection over land. This is a case that has been, there's papers by Wojciech Grabowski and others on intercomparisons, and we use the typical the typical case. And here we have just two figures. So one tells you cloud base and cloud top. So it's time in the horizontal and height in the vertical. And the second one tells you about the rain rate, the cumulative rain rate as a function of time as well, for both the LES experiment that we've run with about 100 meters horizontal resolution and the MF experiments, which are sort of ensembles because it's a stochastic scheme, so we can run a bunch of them and we'll have an ensemble and a mean or a median of the ensemble and so on. And
associated with a host land model, pardon me. It's important to note that FATES is host land model agnostic. So there are some data sets that are shared across all host land models, but if you add supplemental data to be used in FATES, it is not a requirement within FATES. This gives us a lot of flexibility into what you can test, which is great. And so if you look here at the left, you can see the host land model provides climate and site conditions. We've got a short list of host land models that work with FATES now. All of those host land models use NetCDF to read and write data sets. And then just to reiterate, FATES handles all the vegetation structure, physiology, seeds, and litter, as well as roots. So if you're adding a supplemental data set, some things to consider: what are the dimensions and attributes of that data? What's the best way to handle it? FATES has the capability to adjust the units based on the host land model format. It has that functionality now. Or you can ask FATES to force unexpected units based on how it will be used within FATES. And so two main ways of reading data that I'll talk about: stream files. And these are within use in CTSM at the moment. And so, but we've made some updates for functionality to confirm functionality within FATES. Stream files, it's a data format for controlling input data that's part of SEAM, and so it operates outside of FATES. It has a lot of power and flexibility to handle data without requiring us to write a lot of custom code. Stream files interpolate spatially as well as temporally, which is great. And then it uses existing user-defined interpolation options, and so you can decide what sort of interpolation you would like to use. Whereas surface data sets, like the PFT fraction map, the data is fixed on the file at read time. The data is held at the model resolution at the surface data that the surface data set was created. It's also fixed in time. And so Rosie will talk a little bit more about the PFT map. We've identified a core set of essential data sets for global simulation. I've got a table here with a description of the data, where it might be used within FATES, and then the type of data set as well as its status. And so you can see that on this list, we've got data sets that are operational or ready for testing with minimal effort. And so Charlie talked specifically about the land use history. And so that version 1 area base is in testing now, close to operational. And then we've had some updates to lightning strikes as brought in from CTSM, that's also operational. And so with looking at the use of data from the host land model to FATES, Sam Levis and Eric Kluzik recently went through an effort to bring in the lightning strike data that's used by CTSM and have that be accessible within FATES. And as part of that effort, they've created a generic template for adding data sets as stream files. And so that framework is adaptable for other data sets. So the host land model evolves that data set and uses methods that are independent of FATES through SEAM. And so this is outside of FATES. We can also consider having data that would be owned exclusively by FATES. The benefits of this would be the data is available regardless of the host land model. For this, FATES would need to add an efficient IO library, which is also something it does not have, but perhaps worth considering. We've got a couple of optional data sets. Not going to talk about these so that we can move on to Rosie's talk, but you can see that a lot of these data sets either need to be created or a small set of them need to be tested. And there are many other optional data sets that we could add to this list. vegetation structure used for initialization of the model. It is operational right now at the point level with a single point or a set of points, and then the prescribed soil moisture does exist as a stream file from CTSM, but we would need to test its functionality within FATES. And so this presentation will be available for people to go back to. I just wanted to have it as a reference for our discussions. And so these are notes about specific optional cases that I thought would be of interest. Again, we can go back to these in the breakouts. Something else that has come along just with development are grid cell level balance checks for carbon. So carbon mass balance checks are operational. Water and energy balance are in progress. And so these balance checks span the dynamic land cover change along with the physics. And so they handle the interaction between the grid cell and the atmosphere. And so it gives us a lot more capability to capture mass balance problems. Harvested wood and crops are removed from the land model, either for use or consumption. And so this grid cell level check is capturing that. And then we have the addition of a quote unquote dribble term, which takes annual transient updates and applies it across individual time steps. And then I've got the equation down there. So with that, we've got a lot of data sets that are ready for testing or operational. We have a generic framework which gives people the ability to add new data sets as they might need or desire. The grid cell level balance checks will give us an important level of testing. And then a final important piece is that at the moment, the FATES connection to Megan needs development. It is not functional. So that's something to keep in mind as well. And so this being a data talk, and with quote from Yoda, you will only find what you bring in. And then with an eye towards the movie that this came from, let's move forward into the future with hope and optimism and not be afraid of all the complications that might come our way. All right, I'll pass it over to Rosie.
That's great, thanks, Jackie. While we're switching over to Rosie's presentation, I appreciate folks using the chat, and feel free also, I guess this is one of the benefits of having an online meeting, is that you can have these kind of side conversations and not wait to go get coffee, which will be in another 20 minutes or so. So just jump in on the conversation on the chat as much as you can. Rosie, take it away. I think you need to unmute yourself there, Rosie.
Unmute. There. Right. Okay, cool. Okay, so that spoiled my joke. Okay, so hi everyone. So my name is Rosie Fisher, for those of you who don't know me. I was previously a scientist at NCAR, and I'm an affiliate scientist at NCAR, and I work at a place called Surfax, which is in Toulouse in France, for various reasons. And so I'm going to talk about an sort of activity that we started a couple of months ago to introduce a suite of what we're going to call reduced complexity modes in FATES for various reasons. And I think I gave this talk title to Will in an email as kind of a joke, but nevertheless, this is my alternative title slide. I should say that individually, I've always really liked the space filling properties of marijuana leaves. I've never been cool enough to actually take drugs, but like I always wanted to have a picture of marijuana leaves in my life. But anyway, this is my chance. So anyway, the fate simulations, just dive straight in here. Currently, by way of an example, have a high bias for both leaf area index and GPP, right? So this is a reasonably common thing that happens in coupled land model simulations. And so the problem is with these type of simulation is where you have a high or a low bias, and you have a bunch of sort of dynamic processes going on. It's very difficult to disentangle where the bias is coming from. So in this particular case, this is like a chicken and egg problem around the fact that that this problem of having a high bias in both these properties could either be fixed by reducing the GPP per unit LAI, or be fixed by reducing the LAI per unit GPP, right? So you can fix the photosynthesis parameters, VC max, and that kind of thing, or you can fix the amount of leaves that you get for a given unit of assimilation, right? And so at the outset, with a problem like this, you don't know which of those to do. I could trivially go in and fix this bias with parameters in either of these sets, but it doesn't make any sense to do that in the long run, because you might end up fixing it for the wrong reason. And so after this conversation, we determined that a thing we've been sort of kicking around for a while is the idea of a satellite phonology version of FATES. And satellite phonology is a thing we have in CLM already, the SP mode, which has prescribed leaf area index from sort of satellite data products. And so in FATES, we think that'll help us to sort of disentangle these biases. And so when we thought about how we would go about introducing an SP mode in FATES, we realized we needed two things on the way there, and we realized that those things might be quite useful for other reasons. And the first thing you need to do is you need to fix the biogeographic distributions of plant functional types, by which I mean you get a map of where plant functional types are now, in present day. These are the kind of maps that we sort of typically use inside of big leaf CLM in the kind of default state. So that's the first thing you have to do. And the second thing you have to do is to say, well, when we get these satellite data streams, they typically say, so 1/2 of the grid cell is PFT1, 25% is PFT2, 25% is PFT3, and so we have to kind of modify how FATES works so that we sort of turn off vegetation competition dynamics and have fixed patch areas for given plant plagues, and that is orthogonal to how FATES is designed to work in its fully coupled mode. But it turns out that it'll give us sort of interesting ways of diagnosing where our biases are coming from, right? So our hope and aspiration here is that these modifications will provide this opportunity to make interesting and useful ways of running FATES for a variety of people. And so, so the region complexity modes kind of that I'm going to talk about will allow two different categories of problem to be fixed. Firstly, they allow us to disentangle the impact of different parts of the system on the fully coupled behavior, right? The chicken and egg problem that I described before. And secondly, we'll be able to use these modes to test and use different FATES submodels. So in FATES, we have and are currently developing increasingly sort of sophisticated versions of sort of all the things that are in the big leaf model and an expanded set of those things. So including radiation transfer, canopy structure, vegetation competition, multi-layer photosynthesis, and kind of going much further down our sort of nutrients and allocation and allometry lines. And so all of these different submodels are of interest to different communities. And so the idea is that by allowing us to prescribe different parts of the system, we can have sort of further applications in hydrology, biogeochemistry, land use, biogeophysics, essentially where people maybe, for reasons best known to themselves, care less about the dynamics of vegetation competition and more about, say, sort of flooding. And so this, Charlie already helpfully showed panel A of our figure from our James paper. This is panel B of the same figure, where we kind of introduce this idea of modular complexity as a strategy to manage process proliferation, right? So that this perspective piece is sort of started out as kind of like a download of all of our existential crises about land surface modeling, and we sort of thought the only way through this sort of proliferation of complex processes is to allow ourselves to make these sort of reduced complexity models of a land surface scheme for different purposes. So you might have a simplified model for hydrology, one for sort of physical climate studies, another one for vegetation dynamics, another one for soil ecology. And the point here is that different people's versions of what a simple model is are different, right? And so to a plant physiologist, to a vegetation dynamics person, you're happy with prescribing plant physiology, but just for someone who studies photosynthesis, that would be not useful to you. So our hope is that this is a sort of step along the road to this modular complexity strategy. Anyway, so what we're actually talking about here is taking this full complexity fates mode that I'll try to. I'm in the middle of a huge thunderstorm. Maybe we're all still there. Anyway, so this is what I'm talking about is taking the full complexity mode and sort of turning off various bits of this kind of pared down impression of the dynamics that happen in fates I've got here. So by way of illustration, previously we had in this mode we had stand structure. I should have released that arrow. So we in this first mode, this is the fixed biography mode. What we're doing is we're taking an observed plant type distribution and forcing the plant type distribution in fates to correspond to that, right? So so what that means is if you're like me or a diehard dynamic vegetation modeler, this is like this. Someone asked me on a call the other day, is this cheating? And I was like, yeah, this is cheating from a dynamic vegetation modeling perspective, but really only from that perspective. And so what we do is in the fixed biography mode is we sort of force the model with the observed plant type distribution. And the other mode we're talking about just previously, where we want to get to with this is the satellite phenology mode. And in that mode, we prescribe leaf area index. And from that, we sort of predict gas exchange, and we turn off all of these other bits in red of the model here, right? And so, so this mode we can use to sort of test out our sort of gas exchange algorithms, and also we can use it for sort of short-term prediction of applications. You can imagine using this in a kind of weather forecasting context, or to assimilate different sort of real-time aspects of the system, like soil moisture or indeed leaf area index. The next mode, which is kind of a sort of allied mode to this, is static stand structure mode, which Charlie's been kind of developing and using for a little while, which is in that mode we prescribe stand structure, and from that leaf area index and from that gas exchange. And so this is similar to satellite phenology mode, but in this mode we have more data on canopy composition, so we can have a mixed plant type canopy, and we can have different sort of vertical interleaving of plant types in that system. And so that would be typically used where we had a detailed understanding of the forest demography. And so I think the last mode that we sort of have in the works right now is prescribed physiology mode. And in this mode, we turn off gas exchange and leaf area index. We don't care about those anymore. And instead, we test all these green bits here. So we prescribe observed mortality and growth rates. And specifically, we prescribe them at the canopy level and the understory level. We prescribe the growth rates. And from these growth rates of trees, we allow the model to do plant competition for light and emergent stand structure, and thus plant type distribution. And so we test all these demographic aspects of the model. And Jesse Needham has a paper which is in press, so the first application of that mode. That's already working. And so this is a figure which was modified from a figure that Charlie made to sort of illustrate how the different modes I'm going to talk about look in terms of patches and cohorts. And so this is our full fates mode, where we have patches of different age, and on each of the patches of different age, we can have cohorts of different plant types. In Fate satellite phenology mode, as I said, we have fixed plant types. We have one patch for each plant type in the model, and we would have one cohort with a simple one cohort to simply prescribe the leaf area index we get from the satellite. In the prescribed biography mode, I'll look down here first. In the prescribed biography mode, with plant competition, which is the first way of implementing it, we simply make a filter, and we say in this grid cell there are no longer any orange plant functional types. They're not in our biogeographic envelope, and so we allow the blue and the blue and the green plant functional types to exist on a bunch of different patches of different ages, and all the competition here is working as normal. In this other mode, where we have to prescribe no competition between plant functional types, we instead have sort of the green PFT existing on the green patches, the blue PFT existing on the blue patches, and so on. That's just another way of thinking about it. And so another way of thinking about it is in terms of which processes are on and off for which mode. And in the following slides, I'm going to talk about these 4 different modes here, which are the sort of combinations of fixed biography and competition, as you can see here. And so in all of these modes, all of these things are on: rate transfer, gas exchange, allocation, canopy structure, iterancies, and carbon cycling, recruitment. What differs between them is whether the PFTs share patches, which they do in the competition mode and they don't in the no competition mode, and or whether recruits can exist everywhere, which they can in the no fixed biography modes and they can't in the fixed biography mode. This is just to show what the other modes that I was talking about earlier kind of correspond to on this table. So you have the prescribed physiology mode here where you turn off gas exchange, etc. Right, so another feature of this setup is that, as Jackie was talking about, coming in from the host land model, which is CLM in this case, we have a thing we call a surface data set, which is contains a map of where we think PFTs are in the world here. And so the map that we typically get from the host land model has you can modify it, of course, but the default is that it comes with these 14 plant functional types plus or minus crops. And so in FATES, we don't always want to run with the same plant functional types as we would in the host land model. You can, of course, but if you want to run with fewer plant functional types, you can do this in this new scheme. You can kind of group them into the 6 plant functional types we're going to talk about here, or you can split them up. You can say, I want all the area which is currently occupied by broadleaf evergreen tree to be split up between a bunch of hypothetically different types of broadleaf evergreen tree. So in this case, we could impose, I'm not going to show this, but we could impose a diversity of plant functional types on the system and test how the system behaved under those conditions, or we could allow those things to compete and see sort of how the sort of community assembly processes change the behavior of that idea. And so I'm going to show some results from simulations just by way of illustrating the difference between these modes. And so these simulations are 4x5 degree. That's my favorite configuration of the model. And they're using the 6 plant functional types that I described above. I didn't really describe them, but anyway, I listed them. And they just spent 50 years, just because this is illustrative purposes only. And so without further ado, so this is the default full complexity mode for running FATES. And this is the percent canopy cover for the 6 different plant functional types. Evergreen broadleaf tree, supposed to be here, needleaf evergreen tree, drought deciduous tree, cold deciduous tree, C3 grass, and C4 grass. And so this is just showing what FATES does when you kind of run it in its sort of freewheeling, all the levers on fashion. And so what happens if we turn on a fixed biography mode is we're constraining these plant functional types to only be where they are on the surface data set, right? Caveat, of course, that the surface data set is a satellite product and so on and so forth. But you can see here they toggle between these different modes, and you can see that in particular the evergreen broadleaf trees, there's fewer of those in the FATE simulation than there are in the map. And so if we look at the difference between those two, you can see that fixing the biography means that you get more evergreen broadleaf trees. This is now the delta, and fewer cold deciduous trees. FATES thinks cold deciduous trees should grow here. The satellite data map thinks they shouldn't, etc., etc. And so now if we remove the effects of competition, right? So this is when we're sort of nailing down both the distribution and not allowing plants to kind of edge each other out with competitive exclusion. The difference between those two simulations, this is the effect of competition in the fixed biography mode. is that, for example, FATES thinks there should be more evergreen trees up here than are actually observed. And it thinks there should be less see-through grass, which is actually the wrong way around to how you imagine it should be. But I think I know why. Anyway, the most interesting map is this one, which is the impact of allowing both of these things. So this is allowing, so the difference between when you allow free biography and competition to when you kind of fix both of those things, right? So this is, these are both the full set of biases caused by dynamic biography, right? And so I guess the most egregious difference we have here is that basically in the fixed biography, for the moment, the broadleaf evergreen trees are outcompeted by the dark deciduous trees. But what this really shows you is that these are the biases that we need to correct to get a sort of a global dynamic vegetation simulation which is unbiased. And so this provides like a really nice sort of starting point to address these different biases and think about what's kind of controlling the biome boundaries, etc. So I think this will be very useful for various reasons. At the moment, the fixed biography mode that I talked about is on the FATES trunk. It's pull request 612, which is a couple of pull requests ago. For those of you that are sort of not familiar with this, you can find the FATES code at this GitHub site. This NGT is our Department of Energy sponsored project that funds a whole bunch of the FATES development. No competition mode is on my branch, and I'm going to sort of put a pull request up to that as soon as possible. Caveat is, no competition mode currently only works with patch dynamics turned off on account of a sort of memory problem I'm trying to grapple with still. And at some point we need to kind of have some hard conversations about interactions with Charlie's land use development. And so our outlook for this is that we hope this effort will accelerate progress towards identifying and addressing model biases. How you address model biases, whether they're parametric or structural, is like a separate discussion which we can have. And I guess the main sort of thrust of giving this talk right now is that we hope that this will facilitate migration of CTSM developments into a FATES context via the use of models with fewer moving parts where it's appropriate. And so we hope that all the kind of vegetation model people doing vegetation model development will find that these modes allow them to sort of get like fast forward their development testing to a place where it's publishable, etc., more easily, and therefore they're kind of becoming trained in this FATES process. Yeah, and we're very interested in feedback on this effort, particularly if people have the ideas for other modes which might be useful. It's not always easy to think about what perspective people are coming from, but and that's my email address there. Okay, so that's all I have. I hope you're all still there.
Thanks, Rosie. We have about 7 minutes before the break, and it looks like folks are already doing this now, but if you can, please raise your hand. Kind of moving forward, we'll be raising hands a bunch, and so to do that, you have to click on the participant window, which is in the kind of lower part of your Zoom screen. And you can click on raise hand. So Bill, if you want to unmute yourself and go ahead.
Yeah, thank you all for these great talks. And it's really exciting to see how FATES is coming along and the prospects for getting it into CTSM. I have a kind of general question for all of the FATES developers about the sort of scientific development process in FATES, both now and how you envision it moving forward. And specifically, the fact that FATES is coupled to so many different land surface models. What is your process for sort of deciding that a new parameterization or changing a parameterization is an improvement? Is there a particular model that you're focused on primarily, or what if it improves things in one land surface model but degrades things in another? And what will be the process for that moving forward? Have you worked that out?
So you're sort of talking about like a sort of scientific assessment of parameterization A versus parameterization B. I mean, I guess a lot of our emphasis is on keeping multiple hypotheses in the model where possible. And so for the kind of sort of recent past developments in FATES, for example, we just introduced a new symbolic conductance routine, which we're very keen on keeping both that and the old Bullberry conductance routine. And so, so yeah, I guess multi-hypotheses is something we're really kind of interested in keeping.
So you can imagine one land surface model using one scheme and one using another based on which one they find works best in their context. Is that
absolutely? Yeah.
Okay.
In particular, I mean, I guess we discussed this with the Norwegian Earth System Model group, you know, who have particular interest in like high latitude physiology. They might be more interested in adding more detailed snow processes that maybe hypothetically might be too expensive or whatever for a different climate modeling group. That's probably quite unlikely to happen, but in principle, you could envisage different comp sets, for example, with different things turned on and off being and different parameter files being different land surface models.
Great, thanks.
Does that make sense?
Yeah, it does. Thank you.
Dave, go ahead.
Yeah, Rosie, can you sort of clarify what your vision is, or you and or Charlie or the leadership team of FATES, for the most likely candidate out of all your modes for a target for a potential CSM3, if we're getting bold? Is it the fixed by geography competition, or is it the full blown, or like what's a realistic target?
I mean, a nice thing about this idea is that you can aim for the full blown, but if you have completely unresolvable complexity, then you can fall back to fixed by geography with competition. A note that fixed by geography without all the no competition modes are very expensive. In my experience, the fixed by geography is much cheaper, but the no competition mode is expensive. So that would be it's like 2.5 times more expensive. And so yeah, I guess my vision would be full complexity is the goal, but fixed by geography with competition as the fallback. Well, I'm just saying that though, but we haven't really had a very detailed parallel on that. If Charlie wants to,
that's a nice
chime in.
I agree.
And we'll use SP mode if it's awful, but it won't be that bad. I'm fairly confident we won't have to use SP mode.
and I think ditto. I think I see all these as sort of stepping stones, and also I think I see carbon only as a stepping stone towards carbon with nitrogen or carbon with nitrogen and phosphorus, right? So, if it turns out, I think if it turns out that any of these very high complexity modes aren't doing what we think we can or what they should, then we can dial back the complexity, so as not to fall into the trap of saying, well, here's our great model, but it's too complex for us to actually understand.
I mean, I really do think that it will help the understanding to have these different modes to run the model in. I think it would be very clear, if there's some egregious problem with one plant functional type. I mean, the fewer plant functional types you have, the easier it is to nail the distributions down. And so that's kind of an orthogonal axis of decision making. And so, yeah. There's no one else has their hand up.
I think Laura had a question in the chat. Laura, I don't know if you want to read it or I can read it.
Oh, sure. I was just wondering, I mean, in our limited experience so far, it seems that boundary conditions are, the FATES is sensitive to boundary conditions. And I was just wondering if the biases that you've been seeing, Rosie, in your large scale simulations, if you've explored the degree to which they're sensitive to the boundary conditions in your sort of intermediate complexity mode.
Boundary conditions in terms of climate?
Yeah.
No, I haven't. But that will potentially be interesting. I mean, at the moment, I'm still thinking of the precise implementation of these plant functional types as being very fluid and illustrative. I mean, I should note that I have a sort of separate branch trying to address some of the biases in the drought deciduous model, which I haven't touched on here at all. But that's like a different kind of project. That at the moment, that's the most problematic element of the biogeography issue.
Great. Well, it's 10, so I suggest that we take a little break. At 10:20, we'll reconvene, and I'll I guess pose our challenge for the rest of the morning, and kind of lay some ground rules for how to moderate this discussion. So I'll see you all back in about 20 minutes. Thanks, everyone. Great. Welcome back. It's very odd to walk out of the building here at the Mesa Lab and not see anybody. I hope everyone enjoyed the muffins and fruit. Yeah, so in the chat, I think Roberta put it up there, and I just put it again in case you had something else going on in your chat. It's a link to the questions that I'd like us to discuss today. And then also in response to the Wordle in response to the survey that we sent out last week, the first question is, what scientific questions would you like to be addressed with CTSM and FATES? I just made a Wordle out of everyone's responses, which is kind of fun to look at. It's kind of a semi-quantitative way to gauge, questions or topics that people are interested in. So, not surprisingly, things like FATES, climate change, CTSM all stand out. But there's some other ones that are surprising, like more crop and Holocene. Land use change, not surprisingly, comes up quite a bit. Carbon, soils. So it's kind of a fun thing to look at. But in your responses, many of you had questions that the rest of us did. Wanting background information, especially about FATES. And so we had presentations from Charlie, Jackie, and Rosie to kind of give a crash course on information about FATES. There was a lot of questions also about FATES. Oops, I'm going backwards somehow. Questions about interactions with current and future land model development. So Rosie touched on this some in her talk, but ongoing work with the crop model, with fire, with land use and land cover change are all obviously topics. Then we're also lots of questions about benchmarking and validation, especially using satellite or remote sensing data. So again, both Rosie and Charlie kind of talked about these reduced complexity modes where you could use remote sensing data as potentially inputs to force FATES in a prescribed biogeography mode, or potentially use those as ways to validate FATES in a freely running or configuration of FATES that's has prognostic biomass, for example, in plant distributions. And then also a lot of concern about alternative configurations, COMSETs, and reduced complexity modes, both for historical configurations, but also for other, other configurations that CESM and that CLM are used for. So AMIP runs, paleo, climate, numerical weather predictions. I think all of those are really kind of fair game. So you'll see in the survey, if you've kind of started flipping through it already, in the questions that we have you answer, like those three, we have questions that address those three categories of topics. And what I'd encourage your breakout groups to do is find the question or the section that's most interesting to you and start there. You don't have to start necessarily on question one. You can kind of bounce around as the discussion moves along. And so just to kind of orient everyone, our goal here is to be able to run CMIP compatible, fully transient historical simulations of CTSM and FATES. We'd like to do that by next summer, really with the goal of having this be, hopefully the A version of FATES CTSM be the default for CESM-3. So then we can run with it. There's a lot of discussion in the chat about running, with CAM, with CAM forcing, not a data atmosphere. So that's what we want to be able to do is for CESM-3 to have a CTSM-FATES configuration on by default. So the aims of our discussion then are to prioritize the needs and identify specific tasks, and then most importantly, the interested people who are interested in kind of implementing this CTSM-FATES integration. You can kind of gauge from everyone's talks that there's a lot of work to do, and we really do need the community to help. So along those lines, during this discussion, please keep in mind the code of conduct. So offer constructive feedback, consider new ideas, show appreciation, and also encourage innovation. Acknowledge teamwork. I think that's one of the things that this group in particular is good at, and then also share the air. So we'll talk about how to do that in a little bit in this kind of unique virtual setting. So we'll have 90 minutes for our discussions, and we will get to have brief introductions. So it's there was over 90 of us online before the break. There's kind of roughly 80 of us almost online now. So introduce yourself, but remember there'll be 13 people or so in each breakout group. So the introduction should be brief. Again, the topics for the survey that we'll discuss today broadly fall into these three categories, talking about model capabilities and capacities. model benchmarking and evaluation, alternative configurations of the model, concepts, reduced complexity modes, and other support. And what we've done is we'll break out into breakout rooms, and each breakout room will have one FATES and one CESM or CTSM moderator. In your discussion, I'd ask you to raise your hands again to kind of share the air and let all the voices be heard in your discussion group. And then as you're working, record your answers. You know, what I need people to do, what we need people to do is submit your answers on the Google form that's in the chat window now. And that's just to help collate the answers into one place so that we can spend, a smaller group of us will spend some time this afternoon synthesizing those responses, and we'll share out again tomorrow. And so, you know, this afternoon we'll synthesize and kind of share with the group what everyone came up with. But I realized that idea of submitting on a Google form is a little bit challenging. And so I just took a screenshot of the Google form. Some of you are probably looking at it now. And, you know, from your group, I'd like you to submit that. It needs to be in by 2:30 this afternoon, just because that's when we're going to reconvene to kind of debrief and start looking at those. But as a group, it might be easier to work from a Google Doc. So when you go to your breakout room, we'll send you a Google Doc, and maybe that's a place where everyone can be writing or taking notes. And then at the end of your discussion, you can paste those back into the Google form.
Well, can I
just
get a point of clarification there, Dave? On this, really just per group needs to submit this document, not every single person.
Yep. Yeah, not every single person needs to. In fact, the group submission is actually encouraged. That said, everyone has access to the Google form. So, you know, as you're making lunch this afternoon, if you think of something or you have a question or something else comes up, that Google form is also a good place to add stuff. Again, just to keep track of, you know, all the ideas that we generate here today. But yeah, one per form or one per group would be great. So, you know, Jackie shared this blog post with us, and this image I think is very appropriate in thinking about the meeting that we're having now. So, you know, just like the Jedi Council will go into virtual meetings, and in there you'll have two moderators. So those are your CTSM and FATES Jedi. And I realize that I'm going to probably take this analogy too far because I think it didn't end up well for the Jedi in the movie after this meeting. So we'll try to avoid their mistakes, but I think that our stakes are a little lower in many ways than it were for the Jedi. So you'll go to your meeting, you'll have two Jedi in there to help kind of navigate the conversation. And, you know, right now none of us can really see each other. None of us can really see each other or talk. And so as much as possible, I'd like you to mute yourselves, but keep your video on. And I'd encourage you to use this gallery view feature in the breakout room. It just helps you see everybody. So if you have enough bandwidth on your, you know, on your Wi-Fi connection, that's a great way to actually visually see the people that are in your breakout room. So again, keep your video on and mute yourself if at all possible. And then raise hands. So to raise hands, again, you have to go to this participant tab. That'll give you the little blue raised hands, and that helps, you know, the moderators of the discussion, the CTSM and FATES moderators, see who's there, but then also use the chat. So if you have, you know, questions that maybe are as pressing or follow-up comments, please use the chat as much as you can. And then we'll also need some scribes, you know, someone who in the group who's willing to take notes. I've realized in doing these meetings that it's a lot to try to manage a discussion, watch the chat, you know, acknowledge people that are raising their hands. And so we haven't picked out someone who can take notes, but I think that would be useful. When you go into the chat, when you go into your breakout groups, then, you know, introduce yourselves, and as a group figure out where you want to, you know, use the questions as your guide, but then start that discussion. If at any time you have questions, if you have problems, you can ping me or Roberta or Tracy, and we can come into your meeting if you have questions or if you need help. But otherwise, if there's I'll kind of wait a minute. If there's any questions from the larger group, feel free to raise your hands. And otherwise, I'll ask Tracy to put us all into breakout rooms.
Will, can I ask what happened? What do we do if something's going wrong? Like we lose track, we can't get into our breakout room.
Yeah, come back here and let us know, I guess.
This will stay open.
Yeah, the main meeting stays open.
Okay.
Yeah, so I guess similarly, if you get booted off the call for some reason, you can join the main breakout room again. Tracy, it looks like folks are going to their rooms. Have many of you received an invitation to a breakout room?
Yeah.
Yeah, great.
I got one. Should we go for it?
Yeah, go for it.
All right. See you on the other side.
Okay. Adriana, have you gotten an invite to a breakout room yet? There you go. Are other folks that are still here getting assigned to breakout rooms? Oh, it's just going slowly. I get it. Jennifer, I think the invite should be coming. I don't know if you're still on.
Hi, Will.
Hello.
Yeah, this is Elis. Can I change my room?
Oh, you want to change it? Sure.
Yeah, I guess I was in the wrong place in the first place.
Oh, really?
Can I be in the room 3?
Sure. I think Tracy has to maybe assign you there.
Yeah. All right.
I don't have that power. So let's wait until she gets everyone else.
All right. Thank you.
Yeah, Tracy, if you want to go ahead and send, it looks like folks are joining. If you're still here in this room, please go ahead and join the breakout room that you were invited to. And Tracy, do you mind sending Ulysses to a different room, maybe room 3? I don't know if that's possible. Jennifer, have you gotten an invitation to a room yet? No, okay. So Tracy, it looks like some folks still haven't gotten that invitation. And Tracy, it looks like I was assigned to a room, but I don't need to go to one. Yeah, Tracy or Jennifer, any of the rooms are fine. If you've received an invitation, you can just go into one. Let's see, Ned, have you received an invite to a breakout room? So it seems like there seems to be a bit of a technical glitch in getting the, I don't know, 8 of you or so that are still unassigned to a room into a room. Tracy's going to call IT and see if she can get that figured out. Sorry. If you have received an invitation to go to a breakout room, at least on my screen, there's a little box at the bottom of the Zoom window that says breakout rooms. You can click on that and maybe you've received an invitation. If you don't have an invitation, we'll try to get you one shortly. Or we can be the misfits that didn't get a room, I guess. Tracy, have you found anything out yet, or are you still working on it for the folks that are stuck here with me? Great. I wonder, or if the folks that are still online with me here, if you're on the Zoom live stream, you may need to join the Zoom meeting itself. I'm not sure, and then if you join the meeting, then we can probably give you a invite to one of the breakout rooms. Okay, so yeah, it looks like Ned's on the live feed too. So let me go through. Let me find the information to get you onto the regular Zoom feed, Ned and Jennifer. I think that might be what the problem is. So I dropped the chat in with a link to I don't know if you can even get this on a live feed. So in the chat though, there's a link to the Zoom meeting, and then what you'll need is this web password to join. Ned or Kevin, Sherry, Dong Hong, or Nong Yu. I don't know if you guys can join that way. Jennifer, you found us again. Tracy, I think that Jennifer should be able to be put into a room now. Oh, there she goes. Yeah, so I think that must be what we need. So Ned, I don't know if you still get a password error, huh? I don't know what to tell you. Tracy, do you have any ideas if Ned's having a hard time logging on? Ah, Ned, you're there now. Ned, hopefully we can get you into a room this way. All right. Tracy, can you send Ned an invite to a breakout room? Ned, have you gotten an invite this way? Yeah, all right, great. Hey, Mark.
Okay. You will. Where is this? Okay, so now we've, I just muted the echo chamber, sort of.
Maybe.
All right. Okay, so it looks like there are going to be a handful of people that for whatever reasons aren't going into the rooms. And we can't figure out if it's something that they're doing or if it's something else. I was able to join a room, or Tracy assigned to me a room without any problems.
Right.
There's also seems to be the problem that if they leave a room, they can't necessarily get back in. And then the last one is once they're in a room, Tracy loses control over what happens. It's up to the user to do something.
Okay.
But you can pop into the room to private message them.
Right. And Roberta, were you able to send a private message to the folks that are in the rooms?
I was, yeah, and I actually asked if they got it. I had to go into each room, but yeah, it worked.
Okay. Okay. Yeah, is there any way that I can pop into rooms? Right now I'm only...
You can.
Oh, I can, okay. Because I'm only assigned, it says I'm only assigned to breakout room 4.
As a co-host, you should go into your, like the more at the bottom of the 3 dots and then join breakout room. That's how I'm doing it as a co-host.
And Will, this is Tracy. Can you hear me?
Yeah.
So the people that I see under the participant list that aren't joined, like Mark said, I don't really understand what's going on because they've been invited to these rooms, but they haven't joined it.
Okay.
So
Ned logged on some other way, and he so that the Ned that's still there is no longer active. I was going to remove him, but then I remembered Ryan or somebody saying you shouldn't remove people unless you really want to.
Well, what happens is if you do boot them, cannot come back in.
Yeah, yeah. I don't want to. So I don't want to. I'll leave. Oh, there's dead Ned. Yeah. So now it's just there's 3 more folks. I don't know if they're even there.
Well, and that's the thing also. When you are assigned a room, a pop-up appears and you have to actually accept that invitation.
Right.
They took off and went to the kitchen.
Right. They're not getting in.
Exactly. Yeah. So
yeah, I show 3 people right now not in.
Yeah. All right.
Yeah, it's not bad.
So I kind of hate to say this, but we'll have to use the old sysadmin of if nobody's complaining, then it's okay.
Right. That's what I was assuming.
Right.
I was just getting in the chat. I was getting notifications from Jennifer and Ned, so I knew they wanted to be in a room. But it looks like they are now, so that's good.
Good.
Okay, then we'll call it good and declare victory and retreat.
Yes.
Sounds good.
Okay.
Just keep sending me a message if you need anything, Will. I'm here.
Okay, sounds good. And so Tracy, can you monitor? It looks like Christina just joined us.
Let's see. Yeah, I can. So she popped up as unassigned, so I'm going to put her in a room.
Okay.
So she's in there now, or I sent her a breakout room, so she should be able to join.
Great. And then is there any way, do I need to do anything on my end to have go into any room other than breakout room 4? Roberto was saying something about 3 dots.
If you go to the bottom of your screen to more, click on more, and the last thing option is join breakout room, and they'll give you all the breakout rooms, and you pick the one you want.
I don't have.
I mean, that's how it worked for me as a co-host, so it should work the same for you. What do you think, Tracy? Is that right?
More under participants.
Let's see.
So Will, at the bottom of your screen, you should have
Mine
mute,
does that.
not video, participants, chat, share screen, record, join breakout room.
And mine just says breakout rooms. When I click on it, it says go to 4. Just find them.
On the right side, it doesn't give you anything in that breakout room box that says join.
You know what? Once I was actually in a breakout room, I could move between them. So I was first assigned to like room 4. I went in, and then I had the option to move to a different room.
Okay.
So maybe you need to do that.
Okay, I'll try that. Great.
Send me a message if you need something, though.
Sounds good.
Okay. Good. Thanks, Mark.
Roberta, you just put them all in the waiting room, huh?
What's that?
You put everyone who wasn't participating in the waiting room?
I didn't know.
Oh, you didn't?
No.
Oh, someone did, it looks like.
What do you mean?
I just see that there's 3 people in the waiting room.
Oh, I don't know why.
I don't either.
That would be weird because I think Tracy would have told us if she did that.
Yeah.
So I don't know why they're there. We can chat with them. See, maybe we should ask Tracy first.
See if they want to come back in. And it looks like Li Zhao is joining. I don't know if Li Zhao, you can turn on your audio to. Hello. Li Zhao, I was wondering, I don't know first off if I'm saying your name.
Hello.
Right. Hello.
Hey, Will.
Hello,
hey.
How are you?
Good, how are you?
Good. Were you able to join the first part of our meeting?
No,
I was
in another meeting, yeah.
Okay. So just kind of to fill you in, we've broken up into breakout rooms and we're discussing some of the stickier details, I guess, of CTSM and FATES integration. So I don't know if I can drop you into one of those breakout rooms, but Tracy is here and she can. If you'd like to join one of the conversations, they're only 20 minutes into their conversation, and we'll be talking for about another hour. Yeah.
He is assigned to breakout room 5.
Oh, okay.
So
okay.
So do you have an invite on your screen, Li Zhao?
I have a button. Oh, okay. I see that.
Yeah.
Okay. Yeah.
So
okay.
when you hit the button, you're gonna get
Got it.
into another room. But you can come back and see us if you need to.
Okay. Got it. Okay. Thank you.
Yep. Thank you.
Will, do you want me to leave those 3 people in the waiting room?
Did you say something in the chat to them like we stuck you?
No.
Maybe let's do that.
I can. Dan, sorry, I'm on the phone with Dan too. Dan,
okay.
Should I just admit them all back in? Just leave them.
Yeah, go for it. I was just trying to test to see if it would present them with the breakout room option again in the middle of the screen with nothing else around it so they can see it.
Okay. Let's see if it didn't give them back to me. They're after I took them out of the waiting room, it just put them back into the breakout room where I originally had them.
Oh, okay.
So I think they're just not joining.
They're not participating. Okay.
Yeah. I think everything else right now looks okay.
Yeah, great.
Okay.
Yeah, I guess I can put something up on the chat saying or asking for them to join a room if they want to. I guess
yeah.
They're just not around. They're active on the link, but that's it.
Let's see. Yeah. Okay, Dan, I think I'm good. I'll talk to you later.
Okay, cool. Awesome. Thanks.
Bye. Okay, I'm going to mute myself again.
All right. I was going to say, I don't know that we need to record this part of our meeting, Tracy.
I just didn't want to fool with anything because
I was about to hit stop and then I was like, well, maybe I shouldn't do that.
Yeah, I'm just going to let it go because Ryan, all the IT guys can fool with the recording and do whatever.
Okay, that sounds good.
You know, they can, Ryan's good at figuring out what to splice. So I think he'll be able to fix it up.
Okay, sounds good.
Okay.
Thanks. Chuck, are you trying to join one of the discussion groups?
Hi, Will. It's Tracy. I just popped into all the breakout rooms. They looked like they were doing well.
Doing good. All right, great. Thanks. I kind of cycled through too.
Yeah. It is pretty iffy how you can do this.
It is cool. Yeah.
Yeah.
It's nice. I feel like I can't tell if I'm disrupting their conversation or not when I pop in. Some groups were like, "Hi, what do you need?" And other groups were like totally ignored me.
Yeah.
Cool. It looks like someone else, Chuck, recently joined. I don't know.
I let everybody in and lets me know as soon as somebody joins.
Oh, definitely.
Chuck also says my mic is not working, so I have to skip the group.
Oh, all right. There you go.
And I did save the chat, so we have that.
Okay. I couldn't tell when I was popping into the other rooms. Like the chat got all messed up, and I like went back to the beginning of the day basically. So it seems like it keeps a record of everyone's chat. You know, I was going to kind of cycle through all the rooms in like another 20 minutes or so, just to remind folks that we're not reconvening and to start putting pen to paper. But I guess I can't. Is there a way to send out, like, the other thing I was curious, we're still kind of unsure as a group how we want to handle tomorrow, if we need breakout rooms or not. And most of that's just going to depend on numbers. And so that's what the survey was for, that I think Elizabeth was able to.
Let's see. Bertie, are you there?
I'm here.
Did you send that out yet? I was going to send out the poll, right?
Yeah, I don't have it.
Okay, so.
Yeah, that's it.
There it
so
is.
they're looking at that, and then get everything's else is out, right?
Yeah.
What you needed, Will?
Yeah, I think everyone else, they have all their stuff. Thank you for handling that.
So so Tracy, do you think the poll is going to all the breakouts?
It should.
It should, okay. I could just ask like Peter Lawrence if he sees it, just to test it. Can we do that?
Sure.
Okay. Do you know what group he's in?
Let me look. He's in 4.
4. Okay. I'll be back.
It didn't. I just popped into one of the sessions, and the poll wasn't up. So I don't know if you have to drop into each one.
Let me go into the groups and see if that'll work, okay?
Okay.
What office are you in, Will? Are you in your office?
In my office, yep.
Wow, how is it?
It's quiet.
Yeah.
I knew that was not going to happen at my house, so it's a little surreal to be up here, but it's fun going down to where all the IT people are. There's actually like people in the building.
Oh, that's nice.
Otherwise, you're right. It's weird with all the construction around, and no, it's a ghost town. Lisa, did you get booted out of your meeting again?
Yeah, sorry to interrupt you. I just sent you a.
Oh yeah, we're not talking about the urban model.
Okay. During the whole session.
No, we just so we decided as a working group that we wanted to have a CTSM-FATES discussion anyways, but we decided to focus all of our attention on the CTSM integration. But I would encourage you to just reach out to Keith.
Keith Alderson?
Yeah.
Okay, sure.
He's the one who in-house that's doing all the urban model work. And I don't know how much, he's the best person to talk to with your questions. Yeah.
Thank you, Will. Yeah.
Sure. Thanks for joining.
Thank you.
Yep.
Okay, so I popped in to a few of them. It doesn't give me the option to send out a poll in those individual breakout rooms.
Oh, okay. So maybe I'll just ask for a show of hands when I go into the rooms. Who's playing here? I'll just do a manual account. That's totally fine.
Do you want to send this? Well, I don't know. Do you want to send this poll first thing in the morning for tomorrow, or would
I'd rather just. I think I'd like to get a sense. If we're going to have another 70 people on the call, then we'll probably do breakout rooms again. If we're only going to have 20 that want to come back for the second day, then I'll just stay in one room. So I'd rather just get a sense of kind of rough numbers, who's going to join, so we can make a plan for moving forward. Because if we do have breakout rooms, then I'm assuming we'll do the same thing. I'll send you a list of moderators and you can assign them to rooms.
Okay.
Do all that again.
Sounds good.
Yeah, it's interesting. The kind of the kind of coordinators within the working group all have different kind of dichotomously different opinions about this. So put them all together and let them all talk, and other people are like, oh, break them out into groups. So
right.
It's funny to try to navigate, and it's totally based on personality. Like you could probably guess who the 3 people are that say keep it all in a big group, and then there's another 3 people. And it's good that the 3 people who are like break it into groups are like sticking to their guns.
It's good.
It's entertaining to try to navigate when even amongst the leadership there's fairly strong disagreement about how to do things. So
it's all good.
Yeah, it's when I say strong disagreements, it's nothing bad.
Right.
I've been getting a couple questions on emails, so I might pop into individual breakout groups.
Okay.
Yeah.
All righty.
All right, we'll see you guys in a little bit.
Bye.
looks like you guys are, a whole bunch of people are getting sucked back in. Thanks, everyone. We'll see you tomorrow at 8:30. Thank you.
Hey, Will, I guess I should just leave this going until we're sure everybody's done.
Yeah, that's what I was going to ask, if you could do that.
Yeah.
Yeah, again, if Ryan wants to stop the recording, and that's fine.
Well, he told me, I asked him about that and he told me not to touch it.
Hey, I'm here. Yeah, so I was just trying to get the breakout rooms recorded just in case anybody wanted to view it later.
I guess I should just leave this going until we're sure everybody's done.
Sure, that's fine. Yeah, it looks like people are popping back here as they leave their breakout rooms and then leaving, so it's fine. Tracy, can you see on your end what breakout rooms are still active?
Yeah, let me look. So breakout room 1 is done.
Looks like 6 must be done because I see Dave.
Yeah, 6 is done. So there's still quite a few in 5. Donica's just has Donica and Greg.
Okay.
And 3 is pretty full.
Okay.
Those 2.
3 is Rosie's. She's going to keep them there all night.
I don't even think she's in there.
Oh, she left. Oh.
That's Katie's. Rosie is in 2.
Oh, Rosie's in 2. Got it. Okay.
Yeah, they're going. Yeah.
All right. Well, thanks, Will. I'll see you at 2:30.
See you in a little bit. Great. Thanks, Dave.
All right. Well, I'll put me on mute. And it looks like everybody's out. Then I'll stop the Zoom.
Okay.
And then I'll see you tomorrow at 8:30. I'll send you over the chat manuscript from today, so you have.
Okay. Great.
Chat. And anything else you need today?
I thought, so one of the questions I had was yesterday. GoCon sent me a question that came up in the chat, but then I had to email him back, and somehow he forwarded it to whoever asked it, but I have no idea how to find someone's email if they have a question that wasn't responded to in the chat.
Oh, I'll ask Elizabeth.
Okay. And yeah, I guess she has people that would.
Yeah.
Like some people I can